Alright guys, so welcome back. In this video, we are going to analyze algorithms, right? So, analysis of algorithms is that we are going to do, right? You know what is an algorithm, right? An algorithm is just a set of instructions that will do a specific task, okay? It's a step-by-step instructions. For example, you can say a recipe of a food. It's a step-by-step instruction, right? How to cook that particular item, right? So an algorithm is nothing but a step-by-step instruction to solve a particular problem, right? So an algorithm is a step-by-step instruction to solve a particular problem. Okay, maybe okay, it always answers some question, guys. Say for an example, how to make pasta, how to make bread toast, right? So these are some questions where you can give step by step answers, right? Step 1, do this stuff. Step 2, do this stuff, like that. Okay, so algorithm works very similar to that. Okay, algorithm is nothing but a step by step instruction, okay, which will do a particular task. And you can always implement this algorithm using various programming languages, and we are going to implement these algorithms using C programming in this course. Okay, yeah, it's very necessary to know the basics of C programming before following this course. But if you are a CS student, it will be very easy. It very basic knowledge is enough in C programming to understand this course, right? So yes, so we're going to analyze the algorithm. We're going to analyze the characteristics of algorithm, guys. How it is efficient, okay? How a particular algorithm is efficient. How do you identify that? How do I say that the particular algorithm is efficient? Okay, I mean, by what means I could say that? In what terms? Okay, that's perfect, right? In what terms I could say this particular algorithm is efficient? The efficiency of the algorithm is measured in two main terms. Okay, efficiency of any algorithm, right? Efficiency of any algorithm is measured in two main terms. Okay, so one is time, okay, another one is space. Okay, so efficiency of an algorithm is measured in terms of time and space. Okay, time will tell you how much time the algorithm takes to execute. You don't want the algorithm to run for a longer time, right? You want faster results. So here the efficient algorithm would be one which takes the least possible time, right? So the time is the time that algorithm takes to run, and the space is the space occupied by the algorithm, and you don't want a larger space to be occupied by the algorithm, right? You just want a smaller space to be occupied by the program, right? So there are two main factors on which we measure the efficiency of the algorithm. So one is time and space. And when you talk about time, we talk about something called as time complexity. Okay, time complexity, and it is very simple. It is nothing but the running time of the algorithm. Again, running time of the algorithm, I mean, how does the algorithm executes, or otherwise I could say how long does it take to execute. That's the exact way of answering this question. How long, right, how long does the algorithm take to execute? Does the algo take to execute, right? I hope it is recording. Yeah. Okay, let's take an example to understand this even more better. Okay. Okay, let me write an algorithm, guys. Uh, let's say I just want an algorithm to add two numbers. That's it. Very simple algorithm to add two numbers and print them. That's it. Add two numbers and print them. Right. That's the question. That's the problem statement. You have to just add two numbers and print them. Okay. Let's take a very simple example. Okay, let me write the algorithm. So this is algorithm 1. Okay, you can write as many number of algorithms, okay, in different manner. Okay, one programmer would write an algorithm in his own idea, and I would write my algorithm in my own idea, and someone would write write their algorithm in their own idea, right? So let me write one algorithm. So algorithm one is void add. Okay, it will be looking like a program. Okay, because I follow this way of writing algorithm. This is called pseudocode. Okay, it is not the exact C code, but it it is very similar to the C programming code. Okay, so I'll call this pseudocode. Okay, so of course everyone calls this pseudocode. Okay, void add, and you have to get two numbers, right? So first I'll get two numbers, say A and B, right? So I have to get two numbers from the user, then add this add those numbers, store that in another variable. Okay, so how do you write it in C programming? Let me go that way. Okay, the C programming way of writing the algorithm, right? Let me go in that way. It's very simple, right? You have to first declare the variable, say A, B, and the result variable, right? And you have to get A, B first, right, from the user, the numbers that you want to add. After that you have to store the addition in some result variable, right? A plus B should be stored in the result variable. All right, so after that you have to print the result, right? That's it. After that you can close the function. That's it, right? So that's the end of the algorithm. So this algorithm has four statements. Okay, let me go for another way. Okay, let me go for this way. Void add the same function, but this is algorithm number 2. And another way to write the same algorithm, guys. This will perform the same function but another way, right? So again I have int ab and result. I have three variables here, and I'll be getting ab, and I'll be directly printing ab. Okay, so I don't need this result variable, guys. Okay, that is something to be noted here. Okay, I don't need that result variable. I can just declare two variables, and I can directly add those variables and print. Okay, so there is no need to go for me. There is no need for me to go to the next variable, that is result, right? There is no need for me. There is no need for me to go to that variable, right? So yeah. Okay. And the interesting point to note here is I don't have another variable called result, guys. Okay, there is no need for me to go to that variable, right? Because I'm directly printing. I'm not storing it in any result. Okay, I'm just directly printing the addition. So there is no need for me to use the result variable. So yes, of course, I have only three statements. Okay, and I'm I'm getting rid of one more extra variable here, right? So this algorithm is algorithm 2. So that I have shown you two ways to write the same algorithm, right? Both performs the same operation. They will get two numbers and they will print the addition of the two numbers. Okay, but let's analyze these two algorithms. I'll tell you how to analyze the algorithms. Okay, how many statements are there in this algorithm, right? There are four statements. I told you there are four statements in this algorithm, right? And assume that each statement will take 1 unit time. We always assume that. Okay, when you analyze time complexity, you have to assume that each C programming or any programming statement will take 1 unit time. Okay, we don't know that unit. Okay, it may be microseconds, milliseconds, or whatever it is, but it depends on the compiler and processor also. So we'll always assume 1 unit time mathematically, right? So each statement will take 1 unit time. Okay, so what is the time taken by this algorithm? Very simple, right? This statement will take 1 unit time, this statement will take 1 unit, again 1 unit, again 1 unit. This total algorithm will take 4 units of time. Okay, it may be 4 microseconds or 4 milliseconds, but 4 units of time. All right, go for this algorithm. It will take 1 unit, 1 unit, and 1 unit. It will take only 3 units of time. All right, so one statement is not needed here. That's the assignment statement. Okay, so it will take only 3 units of time. So now answer my question, which is more efficient, okay, in terms of time. between these two algorithms, which is more efficient in terms of time. Obviously, algorithm 2, right? Because it takes only 3 units of time, whereas algorithm 1 takes 4 units of time. So, I could say that algorithm 2 is more efficient than algorithm 1 in terms of time because it consumes lesser time, somewhat lesser compared to algorithm 1. So, yeah, algorithm 2 is our winner here, right? So, okay, that's how you have to analyze the time taken by the algorithm. But this is very small algorithm. This won't work. I mean, the larger ones won't go this way. You have to use some other notations. I'll tell you that also. But here, for a simple algorithm, you can do like that, right? Okay. And this is also called as total frequency count. Total frequency count. Okay. It's very similar to how many times the program will execute. Okay, not program, the statements inside the program will execute. Okay, the 4 times. Okay, for the total frequency count, right? So that's in terms of time, guys. Let's go in terms of space. Okay, so space. Let me take another color for space, maybe green. All right, so space. Okay, so let's take algorithm 1. It has 3 variables, guys. One is A, B, and result, right? So it has 3 variables. If you closely look into that, so each variable will take 4 bytes of memory. If you talk about integer, you know that it will take 4 bytes of memory. So those 3 variables will take 12 bytes of memory, right? So this algorithm have 3 variables, and those 3 variables, they they contribute to 12 bytes. Okay, whereas if you check this algorithm, we have only 2 variables, and if I assume that each will take 4 bytes, then this will totally take only 8 bytes, which is obviously lesser than algorithm 1, right? So here it is 12 bytes, means here it's only 8 bytes. So you can see, and algorithm 2 is again more efficient in terms of space also, because it consumes lesser space. It occupies the space of only 2 variables, whereas algorithm 1 is occupying the space of 3 variables. So algorithm 2 is efficient. So by this way I could conclude that algorithm 2, this algorithm, is efficient in terms of time and space, and that's how it goes. Okay, so as a programmer, it's a responsibility that you should write an algorithm which is more and more efficient. Okay, so that's how it goes. There is no need for me to waste one variable here. Okay, just by removing this statement, the extra redundant statement, I got more efficient time and more efficient space. Okay, I hope you have understood this simple concept. Okay, let me brief on that.